So out of convenience, we're going to introduce something a little bit early into the course, and it's called right triangle trigonometry. Now, what does it mean to have a right triangle? Good. It means that one of your angles, exactly one of your angles, is a 90-degree angle. Now, from the perspective of theta, let's label a few things. The first one, of course, would be the longest side. What's the name of that side? Hypotenuse. And it's interesting, the origin of that name. If I get a chance, I'll give you a little history lesson on that. Opposite here, of course, would be the opposite side. And then what's left is the adjacent side. Now, these ideas are only well defined if you have a right triangle. It doesn't make sense to try and look at these things if you don't have a right triangle. If you had, for instance, kind of the extreme, not a right triangle, if you had an equilateral triangle, okay, the opposite side would be well defined. But what's the hypotenuse? What's the adjacent side? Don't know. So this idea of opposite, hypotenuse, and adjacent only works in a right triangle. But there it works really well. And if we have it here, then we can define sine, cosine, and tangent in terms of some sides of a triangle. So, for instance, the sine of theta is going to be the opposite side over the hypotenuse. The cosine of theta is going to be the adjacent side over the hypotenuse. And the tangent, well, let's take a look at the tangent for a second. And you don't have to copy this down. But I know that the tangent of theta is the sine of theta over the cosine of theta. Taking these definitions, the opposite over hypotenuse divided by the adjacent over hypotenuse. If you did a little algebra, you'd see the hypotenuse side cancels out.
So we don't need to know tangent?
Well, tangent reduces to opposite over adjacent. Now, somebody mentioned a little acronym here. It's helped countless students remember these formulas. SOHCAHTOA. I don't know who came up with this, but it works. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. So, yay. Now we're going to use these things to help us construct triangles and then answer questions based on these triangles. And let's start out with kind of a friendly one. And that would be problem number 10. Actually, the first couple will be more on the friendly side. Page 198. So this is section 3.2 now. So sine of the cosine inverse of 1/2. Now I know the first couple here we could probably do just based on our calculator, etc. And that's fine. You could do all right working it that way. But let's try and understand it a little bit deeper. Cosine inverse of 1/2. Can anyone describe for me what that is? What in general terms, not necessarily give me a value, but in general terms, what is it? The angle where cosine is 1/2. I like that. Perfect. The angle where cosine is 1/2. Let's see if we can't draw that. Okay? So this is, and I'm going to use your exact words, the angle where cosine is 1/2. All right, great. Let's draw that. So, and I'm not going to try and draw it with great finesse. I'm just going to draw myself a little triangle here. And there's theta. Now, because I have a nice fraction here, cosine was the adjacent side over the hypotenuse, right? So that would be a 1 and a 2. Okay. So let's call that the sine of theta. For the sine of theta is the opposite over hypotenuse. So I need the length of this side in order to finish this problem. How can I get that? Does anyone know a way that I could figure? Yeah, the Pythagorean theorem. Call that, say, b, or whatever you'd like. 2 squared equals 1 squared plus b squared. And if you play around with this, 4 minus 1 is b squared, so plus or minus the square root of 3, actually just the positive root, right? Because we're talking about a length. Okay. Great. I'll talk more about that being positive in just a little bit. So, b is the square root of 3. Sine of this is going to be the opposite over hypotenuse. So what's the sine? What's the sine of theta? What's the sine of this angle? Square root of 3 over 2. And that's it. You're done. So we used our triangle in a couple ways. We first constructed a triangle that matched this, and then we took its sine. That's going to kind of be our general flow through here. Now you asked about taking the positive square root. Well, I took the, I guess what we'll go over more in a little bit is that this has to be in the first quadrant because cosine is positive in the first quadrant. And I wanted a value here, so when I took the cosine, I got something that was positive 1/2. All right, but are we okay with constructing the triangle? This was our theta, so the sine of theta is the sine of this angle, opposite over hypotenuse, root 3 over 2. Yes, I'm gonna always just call this inside thing here theta, and these problems are all going to be very similar to what we just did. So let's try problem number 12. Tangent of the sine inverse of negative 1/2. Okay. Well, let's think a bit about where we're going to draw this, or how we're going to draw this. Where is the sign negative? In which quadrants? 3 and 4. What's the acronym that helps you remember where all the functions are positive? All. Good. All students take calculus. All right. So sine and everything is positive up here, but not down here. So in quadrants 3 and 4, the sine is negative. But when we take the inverse sine of something, can I get a third quadrant angle? No. So I have to draw something in this quadrant. Let's draw an angle in that quadrant. Call it theta. And what do we know about theta? What's the sine of theta going to equal? Negative 1/2. So let's see if we can't draw an angle that satisfies that. And I'm not trying to draw it to be to scale. Here's theta. Sine is the opposite over the hypotenuse. What side is this one right here, the long vertical side? Well, from the point of view of theta, that would be your opposite side. So let me give that a negative 1. The hypotenuse has to be opposite the 90-degree angle, so that has to be a 2. We've played with these numbers in the previous problem. Does anyone remember what the length of this side is going to be? Square root of 3. Now it's a positive square root of 3 because you're in the fourth quadrant. And here the value of x has to be positive. If we're in the third quadrant or the second quadrant, then you'd use the negative root 3. So drawing the triangle is the big part. Coming up with the tangent here should be the easier part of the two. Not to say that it's easy, but just the easier part. So let me go back here and take a look at the triangle one last time here. This is our angle theta. So theta is an angle whose sine is negative 1/2. Because the sine is negative 1/2, it has to be in one of these two quadrants. We're going to pick this one because that's where the inverse sine of something is going to be. The sine was negative 1/2, which is your opposite over hypotenuse. Opposite, hypotenuse. How do you figure out this one? Pythagorean theorem. So Jeff, I want the tangent now. Tangent was opposite over adjacent. What's the tangent going to equal? Nice. So opposite would be negative 1. Adjacent would be root 3. And I don't know if you noticed or not, but Jeff nicely rationalized that for us by multiplying by root 3/3. So negative root 3/3. You know, when you check your answers in the back of the book, they're going to be rationalized. I'm not as worried about this as I am the rest of it. If you gave me negative 1/3, I'd probably be fine with that. My goal is to see you first draw the triangle and then come up with this answer right here. Yeah, theoretically you should be able to do it. Am I going to make you do it? Probably not. Not so much. Okay. Let's try problem number 18. Cosine of the sine inverse of negative root 3/2. That should be sine negative 1. Start out as before. Let's call this angle theta. When you take the inverse function of some number, you're going to get an angle. And this is the angle where the sine is negative root 3/2. What quadrant does that have to live in? Yeah, 3 or 4, but because inverse sine has as its range quadrants 1 and 4, let's choose quadrant 4. So I'm going to draw this in the fourth quadrant. So what do I know about theta? Well, somebody tell me something about theta. What's the sine of theta equal? Naya? What's the sine of theta going to equal? Sine of theta? Anyone? Yeah, right here. Negative square root of 3/2. These two statements, this one, this equals this, they're equivalent. It's important to realize what this is telling us. I want an angle whose sine is root 3/2. So now fill in your SOHCAHTOA stuff. Which side is which?
Hypotenuse is 2.
So this is the opposite side, and that's the hypotenuse. Hypotenuse is 2. Well, this is theta, so your opposite side would be over here. Negative root 3. So, finish figuring out this side. You can use the Pythagorean theorem, and then calculate the cosine. Want the cosine of theta. What does b equal? 1. It's plus or minus 1, but because we're in the fourth quadrant, the x direction, this side is going to be positive, so b equals 1. Now let's look at the cosine. The cosine of this angle, well, cosine is the adjacent side over the hypotenuse.
So,
This would be your adjacent side. That's your hypotenuse. You should get a 1/2. You know, if you show me the triangle that you're drawing and I see a small mistake like that, oh, okay, you grabbed the wrong side, I mean, it's not going to be as devastating. So I strongly encourage you to show some work as you do these types of problems. It's very helpful for me in terms of giving you as much partial credit as I can.
so if we had a negative 1/2, would you mark that wrong?
Yeah, negative 1/2 would be wrong.
Okay.
Yeah.
So if it's with length, you said it's always positive.
Yeah, you're going to have to look at the quadrant that you're drawing things in. Okay? The x direction here is going to be positive. The y direction is going to be negative.
Okay.
If I was in the second quadrant, that would be reversed. The y direction would be positive. The x direction would be negative.
Okay.
And we're not going to draw things in the third quadrant.
Is it a coincidence that the x-coordinate of that angle we found is half?
No. It's something we'll have a little bit better understanding of later. That that is a familiar angle.
And then, if that's true, can we apply that principle from the tangent?
I'm not sure I see the generalization you're looking for here.
Where I take the coordinates and I solve just using the coordinates.
You know, these are some nice examples that work out pretty pretty straightforward, but they're not always going to work out quite this nice. I'm trying to think of an example where that wouldn't work out so nice. Let me take a quick look at these. Let's try number 16. Okay. So we want the secant. Yeah, already people are blanching. Secant of the tangent inverse of the square root of 3. Understand that this angle in here, or that expression in there, is an angle. It's the angle where the tangent is square root of 3. So let's write that. So tangent of theta equals the square root of 3. Or better yet, maybe it'd be helpful if I wrote it as tangent of theta equals the square root of 3 over 1. Why would that be helpful? Yeah, because now you got two sides to work with, right? Tangent, if you remember your SOHCAHTOA, tangent was what over what? Opposite over adjacent. So we're going to draw a triangle with the opposite side of 3 and the adjacent side of 1. What quadrant am I going to draw this in? Yeah, 1 or 3, but we're never going to draw it in 3. So let's just keep it in quadrant 1. Question? Yeah, okay. I agree. So let's draw a first quadrant angle. Well, let's think about where tangent is positive. Remember, all students take calculus. So it has to be quadrants 1 or 3. We're never going to draw these things in the third quadrant. So tangent is square root of 3 over 1. Let's just throw in a triangle here. Don't worry about drawing it to scale too much. I'm not going to take off points for scale. That's theta. That's your right angle. It's important to keep those two things straight because that's going to tell you where your hypotenuse is. Well, we don't have our hypotenuse yet. See if you can't label these two sides. Which one's which? I think Albie is anxious to share with us his conclusions on that one. So go ahead. What should I label this side here? Square root of 3 and a 1. Cool. Dan, what am I going to do to figure out the hypotenuse? I don't have the hypotenuse yet. Yeah, Pythagorean theorem. So call it, B or C or whatever favorite letter you want. 1 squared plus root 3 squared equals B squared. And you're going to find that B equals 2. All right, good. B equals 2. So we've got theta. We've got this triangle all labeled. So I want the secant of that. All right. Secant is 1 over which function? 1 over the cosine. So let's take a look at that. Let's figure out what the cosine of theta is. So Rebecca, what would be the cosine of this angle? Let's see. Opposite, hypotenuse, adjacent side. So adjacent over hypotenuse, 1 over 2. And the reciprocal of 1 over 2 is 2. Yay. I'm afraid so. Yeah, that's your answer. 2. A lot of work here. Now, if you're wondering, gosh, what do I have to do? Why do I have to do this? You can actually do this kind of stuff in general terms. I'm not going to necessarily do it here. We just don't have time. But problems like 58, sine of the cosine inverse of u, now you don't have any numbers anymore. But you can still do the same process. And I guarantee you there's a lot of Calc 2 students that wouldn't mind a review of that right now. But we don't have to go there. Let's finish up with a couple other problems. Let's just let's take it a little bit easier with some of the next few. Let's take a look at problem number 38. Cotangent inverse of 1. I don't know if TI is going to change it. I think I heard a rumor that they're going to change it. They're going to start putting on some new functions under their calculators, like cotangent inverse. But right now, as far as I know, we don't have this one available. So, kind of stuck. But remember that cotangent is, or the inverse trig function of a number is an angle. Can someone write that equivalently? What's an equivalent way to write this? Cotangent of theta equals 1. Now, that helps us out a little bit, because the cotangent of theta is 1 over which function? 1 over tangent of theta. If I multiply both sides by the tangent of theta, then I get the tangent of theta equals 1. And that's something I can work with. How? Let me go back to something kind of like what I started with, except this time I'm going to rewrite it this way. Theta is the inverse tangent of 1. And that's a number that you can get off your calculator. Some of you might be able to figure that out if you know the unit circle really, really well. If you don't know the unit circle really, really well, that's okay. Yeah. Put your calculator in degree mode again, because you're not going to recognize it in radians, and do the inverse tangent of 1. 45 degrees. (45°), better yet, pi over 4. So we went through a couple steps there to get that last little bit. Let's try another one like that, problem number 42. Secant inverse of -2. So I'm going to start out like it did with the previous one. Let's call that theta. Let's start by rewriting theta. Jacob, how can I rewrite this line, please? Perfect. Secant of theta equals -2. Jamel, secant is what over? Perfect. 1 over cosine. So let me solve and get cosine by itself. I'll multiply both sides by cosine of theta. I get 1 equals -2 cosine of theta. Or divide by -2, I get -1/2 equals a cosine of theta. Please. Take the reciprocal in here? Yeah, we'll get that in a second. Well, you'd have to do two things. You'd have to take the... Well, let me finish this up. So the last step then is to go back with the inverse cosine. Inverse cosine of -1/2 is your theta. So yeah, what you're seeing is kind of what I'm happy that you can see, and that is a little bit of a shortcut here, right? To go from here to here, or from here to here, it's easier to see with this one. What two things are you doing? You're taking the reciprocal of this, and you're taking the reciprocal of this. So you need to do both of those. But yeah, that is essentially the shortcut. And now it's just a calculation. You can even do that on your calculator. So inverse cosine of -1/2. Let's see what the 2 pi over 3. It'd be 120 degrees, and I think that'd be 2 pi over 3. So off your calculator, let's do it off our calculator first. Inverse cosine of -0.5, 120 degrees. or 2 pi over 3. So I'll be specific. I mean, their book's not really giving you good instructions here in terms of, gee, I want an angle between 0 and 2 pi or between 0 and 360. I'll be very specific. I'll tell you where I want your angles. So that'll tell you degrees or radians. Do you want one last one like 42?
Sure.
All right. Let's take a look at. Let's take a look at 40. That one will work out pretty nice. So problem number 40. The cosecant inverse of the square root of 2. Now, if you want to use a shortcut a la problem number 42, that's fine. There is a nice shortcut like that. It should work out as a nice angle in terms of pi over something. Okay, let's take a look here. Brittany, let's start by rewriting this right here.
Square root 2 is equal to the cosecant of theta.
Perfect. Square root 2 equals cosecant of theta. Cosecant is 1 over which function? 1 over the sine of theta. So if I want to solve for sine of theta, I can multiply by sine of theta on both sides. So that gives me root 2 sine of theta equals 1. Divide by root 2. The last step here is to rewrite this. What does theta equal? Sine inverse of 1 over root 2. Now, if you're comfortable, you can take a little shortcut, right? Take the reciprocal of this, take the reciprocal of this. That's getting you to the exact same place. It's nice to understand a little bit about what you're doing, and I'd be happy for that. But if on the test you went from here to here, that's okay too. What's that? I'll be looking at your work, yeah. Now, the last thing to do is to figure out what this is. So, I mean, without rationalizing it, just make your calculator do all the work, okay? Typically, these things work out to be nice, even angles. So I'll do the inverse sine of 1 divided by the square root of 2. Make sure you exit that parenthesis. Your calculator is in degree mode. 45 degrees. Pretty much count on answering in radians. And in radians, for a problem like this, the answer would be pi over 4.
So for this, let's say you didn't have the calculator, you could have just multiplied by square root 2 over square root 2 and then like looked at the unit circle and down.
Yeah.
Right?
Yes, exactly. So if you rationalize that and recognize, oh, hey, I know that one. That's at a 45-degree angle. You get the same thing. Yep. Yep. Good observation. All right. So for homework, let's see. Let's try 9 through 19 and 37 through 47. So 9 through 19 and 37 through 47. Homework in section 3.2. There's a test next week. Make sure you're ready for it. It'll cover everything from chapter 2 up through section 3.2.